So, obviously, we know the outcome of the Titan submersible disaster. This hit close to home for me because I actually grew up on a lobster boat in Maine with my father, so I've spent a ton of time on the ocean. I continued to to work more in that realm, so I was really hopeful for the technical details of a really interesting rescue. Obviously, I was hoping for these people to come out alive. Sadly, that is not the case. And today I want to discuss some of the things that contributed to this submarine's failure and the safety regulations that were completely ignored for the sake of innovation. So, in my opinion, this is the definition of irony because some people just can't see the forest for the trees. You've got a gentleman who is obsessed with exploring the wreck of a ship that at one time was claimed to be unsinkable. So it's complacency with safety that led to the Titanic disaster, saying we don't need the lifeboats. This thing is so amazing that nothing on this planet could sink it. He then proceeds to make the same kind of bold claims, saying things like regulators and safety assessment organizations cannot keep up with his pace of innovation, so he doesn't need them. He's his own oversight. He's so smart that he can go do stuff and then provide his own oversight, double check himself, and make sure that everything is done right. Um, in both cases, these people thought that they were building something amazing, and it ultimately turned out to be the most innovative and cutting-edge coffin for the victims. The motto that safety is not an option might sound stupid and be easily laughed at by most people, but these incidents are why it has to be repeated over and over forever because these things keep happening. So I've already got one quote pulled up that is, pretty illustrative of his attitude. There hasn't been an injury in the commercial sub industry in over 35 years, he told Smithsonian Magazine in a profile published um, in 2019. It's obscenely safe because they have all these regulations, but it also hasn't innovated or grown because they have all these regulations. So, I mean, this is Stockton Rush, the CEO, the gentleman who was, piloting or assisting pilot the Titan sub down to the Titanic wreck site. Um, so he understands the ecosystem of safety that the regulations have created, and then he says, "We don't need them. We're going to ignore them." So, I mean, I think the next thing I got some video of what this would look like if it was a steel cylinder, tubular cylinder collapse. This is being done on land with a vacuum truck. It's an illustration of what vacuum. By removing the air pressure inside, you're increasing the air pressure on the outside. So it's the same concept as bringing this down to the ocean floor. It would behave the same way. And then I've also got a short clip of a movie, and we'll talk about that too. So that is what crush depth will do to a tube. And then this is from the abyss. This is a deep submersible, Hollywood, but so the only thing that's not realistic about that is the delay between the jet of water. Water at that pressure is capable of cutting any material on the planet. Water jet tables are incredible, and that's basically what you're creating if you have a pinhole at that depth. It would be, as soon as that leak started, instant implosion. There would be no no time for a scream or any realization. It's I think the implosion estimated zero point 0.3 milliseconds, if I'm remembering that correctly. So we got some more quotes or some more news articles speaking about some of the things that I think a lot of people are suspecting, including myself. Some expeditions were delayed after Ocean Gate was forced to rebuild the Titan's hull because it showed cyclic fatigue and wouldn't be able to travel deep enough to reach the Titanic's wreckage, according to a 2020 article by GeekWire. Um, so that's the other thing. They only successfully did 2 trips that I'm aware of to the Titanic. There's a bunch of detail here that we can get into a little bit more. Um, but first, I guess I should probably kind of talk about my background. So I grew up on fishing boats. I spent my whole childhood on the water, and then I continued that career as a merchant marine. I was a civilian employee for the U.S. government. We were doing work on subsea communication systems, um, working with an ROV, bringing up these systems, doing repairs and modifications. I've also worked in QC for large manufacturing company, manufacturing metal parts, machine shop type environment. I worked on nuclear naval submarines at a public shipyard that did repair and retrofits. And then I was also I worked in the metrology lab, doing precision measurement on parts, tools, calibrating equipment. So I have adjacent experience, talking about the quality control that's going to go into commercial off-the-shelf parts that he chose to use is not on the level of QC at a naval shipyard dealing with submarines that go underwater and put hundreds of lives in jeopardy every time the submerges. We want these submarines to come back to the surface. And when we're at the shipyard, this was beaten into our heads, talking about the Thresher, um, and other naval incidents that were learning lessons, that were things that we were never going to let happen again, and we put systems in place to prevent those things from happening. One of the things that jumps out to me from my direct experience is the thermal cycling that's going to occur. Um, it's impossible to hold close specifications because you've got thermal expansion coefficients of material. You can look at, for a completely different example on the opposite end of the spectrum, you can look at the SR-71 Blackbird. This is a machine that leaks fuel on the runway because when it flies so fast that the whole fuselage gets so hot that if you machined everything tightly, when everything expanded, you've had a lot of interference issues. So what they did is they manufactured it in a way so that it was actually not in spec on the runway cool. They manufactured it in a way so that when it was up in the air in its flight temperature, everything expanded and worked perfectly because it was a lot more important that the thing worked right when it was flying versus sitting on the tarmac. Um, so we can go through, a couple of the other issues. Communications obviously is a recurring theme. Um, they had problems with their comm systems. They didn't take that seriously. They also had a battery issue and had to be manually attached to the lifting platform, which led to damage to external components. He's bragging about being an innovator who broke rules. He's quoting Army General MacArthur, who said that you're remembered for the rules you break. I don't know if you've watched the movie about MacArthur, but he was not as much of a rule breaker as Patton, who got in a lot of trouble for that. So he might have said that quote, but I don't think he embodied it in an irresponsible manner. You can break rules, but do that in a controlled manner and not put more lives at risk than need be risked. So speaking of some of this thermal cycling that we were just talking about with the SR-71, the most clear issue outside of the pressures of the depths that they were taking this thing to is having at least 3 different types of material on the pressure hull that was protecting the occupants. So you had acrylic window, that was your viewport, which is right here. And it was only certified to a third of the depth that the Titanic was at. So this is 77 millionths. And then if you go to titanium, This is 8 millionths. So it's an order of magnitude different. And 8 millionths is decimal, 5 zeros, and 8. So it's very small, but that is an expansion coefficient per inch. So if you have an 8-foot diameter tube, maybe the sub is 8 or 10 feet, something like that, then that's per inch of the ring. So every inch of titanium, um, that's going to expand and contract by that much per degree. So it can result in very large changes in the structure of the material. And then the worst part, at least these two are different, but they're in the same direction. The worst part is that carbon fiber has a negligible thermal expansion coefficient, but the issue is that it is actually an inverse coefficient. It is a negative. So right here, when the material is heated, it will actually shrink. So ocean pressure is one thing, but the more rigid you make each of these materials and then have an interface fit with another different material, the more that you cause a temperature change, and you're going from probably 60s on the surface this time of year, air temperature, you're going down and you are probably in the 30s when you're actually on the wreck at 12,500 feet. It's near freezing. The salt water is near freezing down at the bottom of the ocean there. So, I mean, this right here could introduce more pressure against the other materials than the actual water pressure in some cases. I mean, if you have something that's very, very strong, if one of these pieces is much stronger than the others, it could actually break the other pieces through thermal expansion and contraction. So that's a huge source of stress. And obviously, there was a notation that they had to delay one of their dives because they were seeing issues from cycling, whether that's the pressure cycling, whether that's the expansion and contraction of the different materials. I don't know, but it was obviously a problem, and that is one of the reasons that all other submersibles are made out of metal. At least the pressure hull section is. There's a lot of other components, but the pressure hull is generally made out of metal. So, even evaluating titanium, when I worked on the shipyard, you had something called SubSafe. SubSafe is a program that tracks any parts that interface with the pressure hull. Pressure hull is where the people are inside of. It's a people tank. Any component that interfaced with that pressure hull, whether it was a fitting, whether it was packing that went in the fitting, any tiny little piece, all of it was serialized and tracked and could be taken all the way back to the manufacturing process, whether it came from iron ore in the ground. You could go back and see what mine it was extracted from, where it was smelted, who machined it. You could see inspection reports. Same things for rubber and plastics. All this stuff was traceable. You could go back and you could evaluate the batch. You could see, who manufactured it, where it came from, and go back, and if there was a failure, that way you can do a full, thorough investigation and confidently identify your failure point to fix it. So, we don't know exactly how the titanium was alloyed, and it's doubtful we'll ever, unless we recover it and do some inspections, we may not know. All carbon fiber is also not created equal because this is supposed to be laid up in a very controlled environment. It's supposed to be done in a vacuum environment to remove all air, because air bubbles are what will reduce the strength in your carbon fiber. Any imperfections, any dirt or air that is causing a bubble between the laminated layers, that is an imperfection and that is a weak point. So there were no inspections done to this carbon fiber as far as what I'm reading. You can do ultrasounds on this. You can use X-ray. There's a bunch of different techniques for non-destructive testing. I've seen them used in a lot of cases. We certainly did non-destructive testing on our submarines. So the fact that they completely ignored that portion is absolutely insane. I've also done some reading about their test dives. Their test dives were done to a similar depth uh, um, as the Titanic, about 4,000 meters. Now, if I was going to ignore everything that had ever been done, metal construction of submersibles, and start to introduce carbon fiber, and then I'm going to shirk regulations and not certify my vessel, if I'm going to do all that, then I'm going to send it to double my depth. I mean, the Marianas Trench is 11,000 meters or 36,000 feet. The Titanic is 4,000 meters, 12,500 feet. So, I mean, even if you just sent it down to 8,000 meters, that would at least provide a 2x safety factor. Now, in a lot of prototype crafts like this, you want more than 2x, just to have that margin of error, because you've got different types of strength in material. Material has yield strength, compressive strength. These are at which point things are going to start to deform. It's called plastic deformation, because if you take the force off of it, it will go back if you don't exceed that threshold. Once you exceed that threshold, you create bends, warps, bulges, things that are not going to go back when you release the pressure. And then beyond that, you have what's called breakable strength. This is the point where you record absolute failure. That's the maximum stress. If you are approaching these thresholds, there's another type of strength called impact strength. And impact strength would be like, okay, my submarine can handle this depth, no problem. But if a current comes up from behind and decides to smash you into the propeller of the Titanic, like there's a reporter that had that happen. He was down there, the submersible was caught in a subsea current, and they got jammed into the Titanic's propeller. They were stuck there for some time. Eventually, the pilot was able to extricate them, and they were able to return to the surface. But even in that case, going back to communications, that pilot was in constant contact with the surface. The surface knew what was going on. The sub was having issues. It was trapped in the propeller, and there was communication, and the team up top could help them figure out how to get out of that situation. So, I mean, if you are already cutting it close, and then you have an impact like that, and everything is already at max stress, then a tiny little bump could be all it takes if you hit the seafloor too hard. If you are at the absolute threshold where things are about to blow up, and you have some sort of unexpected development, you gave yourself no margin of safety. So the consequences are going to be severe. The other thing with this stuff, and this is actually speaking directly to the Titanic, there's also a component called hardness. So hardness speaks directly to, there's strength and then there's hardness. Hardness speaks to how much a material can deform before it gets broken. So carbon fiber is much more elastic than metal, and it's going to be able to deform more than metal would before it actually fails. Um, Another comparison I could make is I know sometimes people with their nails keep getting broken. They'll try to put nail hardener. It's like nail polish that you can put on. I mean, you are technically strengthening your nails in one aspect. You're strengthening your nails in the sense that now they will not uh, break as easily. But if you deform them, they will have less plasticity or elasticity. They will deform less before breakage occurs. So there's give and take with material, and designing complex equipment for extreme depth and extreme temperature change is a very complex process. And even the smartest people in the world are subject to making errors. On the shipyard, anything critical had to be second checked by another engineer. One engineer was never sufficient to make any decision or to make any changes to anything. When work was generated, it was double checked by someone else. If any changes to that work are made, that is also double checked by a second engineer. Second party looks at that. Um, So for simplicity, I guess if titanium and carbon fiber have equal failure point, the carbon will deform much more out of shape before it absolutely fails. Deformation could cause a leak before the material failed, and I would expect that to develop at the section where the titanium ring glues to the carbon fiber, creating a differential strain. The window, to me, also screams failure. So let me pull up the titanium ring. This is the titanium ring being installed on the carbon fiber tube. As you can see, this is not being done in a vacuum environment. This is not even a clean room. There's dust floating around in the air here. Um, there's no way for them to properly remove all the air bubbles out of that epoxy that they're using to glue that on with. So this is absolutely ridiculous. This is the ring before just being slung. I mean, who knows what the process they used? Did they clean it with alcohol? Did they do everything right except for have the vacuum environment? Probably not, based on what I'm reading about how this company operates. So the other thing that I'll mention, this isn't really relevant, but it just illustrates how hostile the ocean is. You got temperature to deal with, you have the water pressure to deal with, but you also have um, electrolysis occurring. And this is not that relevant because this vehicle spends a lot of time out of water. But for things that are in the water, there's another effect that, in addition to corrosion, that causes a lesser noble metal, and titanium is pretty much at the top of the noble metal charts. So any other metals that they're using on this craft would be experiencing electrolysis. So it's just another consideration. When you're in the water, there's chemical reaction, there's temperature variation, there's extreme pressures. Each on its own is terrible. Combined, this is why there's regulations. This is why it's so critical to do things right. And if you're going to change things, then you need to verify that these changes are safe. You need to conduct experiments and really test this stuff. They should have sent that right to the bottom of the Marianas Trench to make sure. And no other alternative. Either comply with regulations or prove how smart you are by sending this thing down there, and prove that it can sustain the stress of what you are trying to make it do. Um, as I said already, there were some things on here that they did not inspect. They were not able to inspect this ring um, after it was installed. For whatever reason, they didn't want to use X-ray, or they refused to use X-ray or ultrasound. Both of those can be used, and you could try to identify. We did these types of inspections on welds. Um, I don't know if there's any welding on this, but this is epoxy is plastic welding, so you can still perform these types of inspections and see if there's air bubbles, see if there's gaps, see if there's porosity, see if there's dirt or any foreign substances that are not supposed to be there. If there's a rock in there, ultrasound or X-ray could pick that up and say, hey, there's a foreign object in here that's weakening this interface and is going to cause more problems. Um, so the other thing, we can just pull these right up and see that this is not certified. They refused to pay the manufacturer to certify that acrylic window to the proper depth. They considered it rated at 4,300 feet, 1/3 of the depth that they're diving to be sufficient. I mean, that encapsulates the corporate attitude right there. It's absolutely criminal. They murdered people by not doing the right thing and not paying the money up front. And these are rich people. Just increase the price. If you want to go to the Titanic, it's $1 million because that's what it costs to do it safely. It's not 250. And if people don't want to pay it, then they don't go. You know, you don't get a fire sale. There's no Walmart of submersibles that's going to take you down to the Titanic. You got one option. There's no price competition in the ecosystem, so it doesn't even make any sense. So the tube wasn't certified. The interfaces aren't certified. The through hull fittings aren't certified or tracked. None of the traditional submersible submarine programs that we have in place were considered or used. So I actually have their website pulled up, and this might be interesting. I don't know how many people know how to get to the website, but OceanGate took their site down. This is the OceanGate website. So the only way to get to this is to take this link right here, and there's another link that I used as well, but you go in the Wayback Machine and you enter that old hyperlink that doesn't work any longer, and there are archives of that site stored here. So that's what I've got pulled up. I'm going to close this stuff, and then we'll move into, this is a blog post. As you can see, it was on the OceanGate website. And this is discussing why isn't Titan classed? You know, they have the audacity to go on and explain in text that everybody can read why they don't need to certify, why they don't need to comply with the same regulations or play by the same rules as everybody else. They can go do whatever they want, which turned out to be true, and they did it. But to justify it, I mean, just keep your mouth shut. Just go do it. If you're going to break the rules and do all kinds of stuff, don't brag about it, because it's just going to come around and bite you, and everybody's going to criticize you and use your own material that you put out to do so. So overconfidence is a theme here, recurring. So I mean, you know, if I'm not going to read this whole thing, but this does go through the whole classification thing. And again, if you want to look this stuff up, I'm going to put links to this stuff in the I can put these links in the description, so you can pull these archives right up. And then this talks about their past expeditions. So this is their blog post, past expeditions, specific Titanic expedition information, talking to you about what to expect, you know, illustrating where the Titanic is, and then they've got some video here. This is the page for their Titan submersible. Really doesn't have a lot as far as technical data for a nerd like me who wants to actually dig in. They don't have much as far as spec sheets because it's all just thrown together. I mean, you can see the build quality right in this panel here. That's not even lined up. You've got fasteners all the way down here. You've got one missing. You know, I mean, it's just clearly, I don't know what this company was worth, but clearly they didn't spend their money on improving this machine since 2021 when it was first deployed. And I would say, I don't know, have we seen the inside yet? So this is a picture. Let's just go through these right now. This is a picture of the Titan with its door partially open. This is kind of like an outside illustration with some stuff. This is a picture of it, pretty stock photo. It looks kind of dirty here. This is another thing with more pieces called out, you know, talking about its capabilities. This is a cutaway illustrating, you know, so this is how people are just sitting in a tube. It looks like there's a mattress on the floor. So they're just sitting on a mattress. The pilot is sitting with everyone else. There's no harnesses. There's no safety equipment whatsoever. I mean, if the thing turns upside down, everybody's on the ceiling. Nobody's strapped in. If you're tumbling around on the bottom, it's going to become a mess really, really quickly. So this, you know, it's to me, it's ridiculous. I don't know what else to say about it. Really, going through this has been pretty eye-opening. This is Alvin. This is a proper submersible. As you can see, you know, they don't have the there's no wires exposed. Everything's clean. You've got guards over your thrusters. One of your thrusters is recessed. You know, in order to get to the cabling and the paneling and things that could get hung up, you have to remove these panels that are protective. They're probably made out of plastic or polycarbonate or something like that. So you take this and then you compare their cockpit to a proper submersible cockpit. You know, it's got a seat, it's got panels of equipment, it's got redundant controls, it's got redundant comms, it's got a place for everything. It's not just a tube with a bed in it where everybody just jumps in and sits around, you know. So this is an image from one of the times that they went down to the Titanic. They got all the way down to the seafloor before they realized that one of their thrusters had been installed backwards. So they remapped their controls. They reprogrammed their controls while they're on the seafloor. Talk about risky. I mean, this is just another illustration of, hey, let's push out new software. Let's write new code while you're down on the seafloor next to the Titanic. I mean, this is just these people don't take it at all serious. I mean, they think they're on an amusement park ride or something. Um, this is the cockpit, and as you can see, just like we've talked about the LED lights off the shelf, everybody's talked about that. You got the video game controller right here. I mean, I play video games. I know all about stick drift. I know how junky these controllers are. I've taken many of my controllers over the years apart to fix stuff because they are not that well built. This is a $40 to $50 item at best. Probably costs the manufacturer like $10 to $20. This is not robust. This is not waterproof. This is not designed to be operated under the sea. This without anything else. Just when I saw the video game controller, I said, okay, these guys think it's a video game. Now, when you're sending a drone up, yeah, the military does this. Sure, military sends up a little drone, uses a little controller to control it. Who cares? If it falls out of the sky, you know, the worst case is maybe it hits somebody because you lose control, it falls out of the sky. Not an implosion that kills 5 people instantaneously. And then you've got monitors. They're probably not marine monitors. They're probably just regular monitors. You got no cable management. Everything's just kind of like, you know, strung in here and shoved under the mattress. I don't know. I mean, I would hate to pull the mattress up. If what you can see, the billionaires that climb into this, if this is what you can see, I bet if you remove more stuff, I bet this is a mess. I bet it's a rat's nest. I bet that these cables are not professionally managed and identified and all this stuff. This thing seems so thrown together. Why would you expect anything else at this point? Um, and then this is a great look at their external cabling. We looked at Alvin, right? Alvin, completely closed up, properly done, professional, submersible. This thing looks like it's day one. I would understand this if it was just built. But this was completed in 2021 and they decided, nope, no more improvements are needed. And I'm pretty sure I know why they're doing this because anything that they got to bring in underneath, they now have to do work to fitment work. They have to do routing. They have to do all this stuff. It's a lot easier to just put zip ties and just run some cables on the outside, you know, like you're working on something under your shade tree, some old truck or something from the 70s that you're trying to get running again. Oh yeah, just put some zip ties on it. Perfect. Good to go. Do we need to make it look any better? No, that's good. That's perfect. I like it the way it is. Your thrusters have no guards on them. Everything's exposed. I mean, talk about getting caught on stuff, right? Like there's no attempt to try to, if you got in a situation where you were up against the Titanic, it's a good chance that you're not getting out of that. So just it looks like a prototype. That's what it is. They made no attempt to bring it any farther beyond that stage, and they're trying to do commercial trips with it and put people at risk who are not subject matter experts. They're offloading their risk assessment onto these people who are supposed to be subject matter experts in the submersible world, and instead they're let down by people that they're not doing it either. You know, we're asleep at the wheel. Nobody's paying attention. Um, so the other thing, kind of we're wrapping up. The last things I'm going to talk about is the communication system modification that CEO Stockton Rush had done. He was annoyed by requests for status updates from the surface vessel, so they actually reduced the communication capabilities of this vessel and turned it into an intermittent check-in and then text messages sent from the submarine to the surface. And this is the reason that so many assets had to be deployed. We didn't know what was going on. The submarine lost communication on seems like every other dive, so they were like, probably just, standard communication loss. They'll be fine. So that delayed response, if they had been alive and trapped, that meant we didn't get any communication from them. So we spent a lot of time and energy looking for them on the surface because we just didn't know where they were. This was so common that we didn't even take it seriously. That the sub was lost. We're like, more than likely the radio went out. The batteries, this thing is such a piece of junk, it's unreliable. We expect it to fail. So the last thing I'll say is, extreme tourism is becoming a thing. You're seeing it on Everest. Now you're seeing it at the Titanic. You're seeing it with space. Space is the next frontier where rich people are just going to want to go check it out. Well, if you're going to send billionaires to space, it's not like you're going to make this affordable for the regular guy anyway. So if you're going to send people to space, then you send people to space, you send people under the water, and you do it safely, and you build that into your cost. And if you cannot do it for that cost, if $250,000 is not enough, then you don't do it. You don't do it on a budget. You do it right. You do it for the appropriate amount so that you can cover all the expenses to bring people back to the surface alive, or you are not allowed to operate. Going out of business is not sufficient. You are not allowed to operate through regulatory agencies stepping in and saying you are not allowed to profit while putting people at risk. You're not allowed to profit on potentially killing someone, and you make your money until you do so. That is not how we do things, and I hope that some big changes come out of this. I hope that that you guys enjoyed the information. I was really hopeful for a positive outcome. They do still have their YouTube channel up as well. I figured people might be interested. It's a pretty hot topic, and people want to understand how this happened, so that it doesn't happen again. And I mean, I don't know. I don't think I would ever do this, but I mean, I guess if it was affordable and safe, which I don't even agree doing that for the Titanic is responsible. This is a graveyard. It's not a tourist destination. I agree with that theme that I keep hearing. This is a graveyard. There are dead people down here. Now, if you want to go check out the seafloor and see weird stuff, there are plenty of places to go do that. At this point, James Cameron has documented a ton of footage, and these guys actually have documented a ton of footage that's on this YouTube channel as well. So I don't see why anybody needs to go down there other than just for bragging rights. So anyway, take care, guys. Stay out of the Titanic tourism industry. That's the moral of the story.